today's session, which is automation engineering. Second one is tomorrow's session, that is going to be communication system engineering. Third one is actually electronic engineering, electronic circuit engineering. Okay, these three sessions are more or less integrated in such a way that I am coming top-down approach. That means automation engineering, in which communication plays a part, and in communication actually circuits plays a part, and so it's going to be top-down, and you will enjoy that. Actually, I am one of the persons who always prefers the institutions to teach top-down. That means the first year you teach the large, say for instance, satellite communication or something like that, and slowly come to the devices more or less at the 6th or 8th semester. That will actually make more relevance to the present day students who are very comfortable with using the mobile phone, etc. These are all my thoughts, and I'm going to be talking. I listened to Dr. Ganga's speech, and it was a good one. So we are not going to get into too much of Labview, because you are going to have a lot of people talking about Labview and Labview based programming, etc. And I am not going to give you the same thing, because I will talk the different aspects of teaching, learning process, or learning teaching process. Okay. Now there are some imperatives I will give you. See, you are bringing a lot of graduates into the marketplace, that is job market or employment market. They will actually, what they will do, they will design hardware or develop hardware, they will develop software, or they will develop combination of that, and they will actually go to the system level ecosystems. Okay, in automation and in IoT, which I'm going to throw actually for the healthcare industry, you will see, if you don't look at anything as a system, you will not be able to get the total perspective of what you are developing. You will develop an amplifier, an oscillator, or a filter actually, but if it doesn't meet the requirements of a typical system, it is as good as useless. Okay, so unless or otherwise you teach system and then try to include the components or subsystems or anything like that, it's not going to gel with the engineer who is going to come out. See, I am from BITS Pilani, as I have been told, and I learned system right at the, I think, first year or second year they teach. Actually, Professor Nagarath, who is supposed to have written many books in control systems or anything like that, and I am taught by that person. Okay, so system is there. So the students or the graduates who are coming out of your institutions, and they will actually either use them or design them, or they have to understand the system level and try to even maintain the system. That's actually what I am trying to say. So your engineers or your graduates must know system level design. Okay, system level. You are bringing that in the 8th semester or 7th semester when you are going to talk about system on chip or anything like that. No, that will not work. You have to come down and go to the 2nd semester or 3rd semester system level design. And I am from CICT. CIC is competency. I'm going to down the line, I will talk what is competency I mean. And ICET, information, communication, electronic technologies. This is what I know little bit. The remaining things, I don't know many things. Okay. And I always believe in do engineering and evolving technologies. Actually, if you really go back and look at it, hey, what is this engineering is telling and what is the technology? I'm going to open it up down the one or two slides later. You should know what is engineering. You should know what is a technology. Please understand, whenever, or you should know who is a scientist. Okay, all these things are being told casually. Scientist, engineering, technology. Okay, so all these things are there, but really speaking, we don't understand how a student should be made to learn engineering or technology or become a scientist. Okay, become a scientist. It is not the degree that matters. It is actually how he develops his mind and tries to create solution for the global challenges that matters. Okay, that matters. So I'm going to talk about closed loop teaching learning process also. In the closed loop teaching learning process, I am going to tell you that unless otherwise you change your lab sessions, into something like closed loop teaching learning, that lab session is a waste according to me, because the lab session, they are supposed to learn by doing, and today they are doing an exercise, just like a physical training or anything like that. They are not learning anything. I have visited more than 800 institutions, including NIT, Nagaland. Unfortunately, I wish to say that most of the institutions treat the lab session as an exercise, not really as an experimentation or learn by doing. That's also I'm going to talk about. Okay. Teaching learning, in this particular session, in the side, actually, I would have given here automation engineering. What I mean by automation engineering, I'm going to talk about why automation, what is automation, how automation is achieved, and GST platform. I am telling you, I'm going to be really give you a bird's eye view of the GST platform. Madam Genga has told something about the Labview and the Industry 4.0. It's more or less the same. So I'm not going to waste your time before lunch, particularly in learning the same thing again, or in listening to the same thing again and again. Manimaran has put a lot of people to talk about GST, and you will learn more about it. And they are better equipped than me in telling about that. So I'm not going to talk about, I am only going to talk about automation engineering. Okay. So I wanted just to give you a small brief preface. Okay. This is actually why all these STTP or all this, or FDP, or even actually learning, etc. is coming, or remote learning, etc. is coming, is because there is what is known as actually going to be a gig factor. This gig economy, I am defined it actually, a labor market characterized by the prevalence of short-term contracts. Please understand, we are not going to believe in having a full-time, lifelong employment. No, it is not going to happen. You are going to be, you have a specialization of Python. I need a Python programmer now, and after 3 months, I don't need them. I will just send you off. That's all. It's going to be a short term. There is not going to be a lifelong employment. If you can teach IoT and you teach IoT this semester, next semester you are as good as jobless. That's all going to be there. Or you learn image processing, and in this image processing, you will have one more semester. You learn artificial intelligence, then you can get one more semester. Like that only. Lifelong employment is more or less gone. Okay. I have practiced not lifelong gig factor right from 1989. Okay. As laid off workers and nervous companies gravitate toward freelance work, the gig economy is moving from fringes to the core. Previously, it used to be one or two. I need one Unix fellow. So I take one Unix fellow and send him off. I need one Java fellow. Take him. But today it's not going to be that. It's going to be only for short-term contracts. New tools and platforms are springing up to support the trend, and an appropriate policy work will be there. Please understand, these are all being cooked in this one. This is given by Economic Times, so it will not be wrong. Reskill India. C++. People say that actually we have, there are institutions who still teach 8085. There are institutions who teach still analog communication as a one semester subject. No, we have gone. It's gone out of our this one. There's no point in teaching analog communication full one semester. You just teach one aspect of the analog communication, that is what is FM, what is AM, what is PM, and what is the noise factor on that, how it is actually going to take care of the noise. That's all. 8085, what do you need 8085? Today we are in a time when people are going to develop their own CPUs. And today still we are teaching about AND gate, OR gate, NOR gate, NAND gate, etc. That's being taught in the CBSE syllabus in the 8th standard, 9th standard, 10th standard. Why are you teaching to the engineering student? No, it should be scrapped. That's all it is. So Reskill India is, I am one of the old, I am the person who has learned almost everything with vacuum tube. Today I can talk about SOC or system on chip because I have continuously reskilled. I am not talking about great, what should I say, I am a great person, etc. No, that was a need. I have to run a company, so I need to learn. I have to reskill myself. So I did that. Today, I am the last person to tell you, you take this tool, you take this tool, you take this tool, etc. Because of the simple reason, Tools will come 100 times, 100 more, 100 more. It will keep on coming. So you should know how to reskill yourself to take care of the challenges in front of you, and if the tools provide you solutions. That's all it is. Okay. This is the reason why we are doing so many things. My session will cover the knowledge aspect in the area I am comfortable: information, communication, and electronic technology. I will never talk too much about skill, because of the simple reason there are other experts in this STTP itself who will provide the skill part of the solutions engineering. I shall indicate, I will tell you something actually, which I will tell you, please do it. Actually, it will be good for you in your profession, whether it is teaching or industry or any other job that you are doing. Okay. And sole purpose is to make more competent, make learners more competent to provide solutions to global challenges. Competency, according to me, is knowledge plus skill. Knowledge, I did RC coupled amplifier in 1963, 64, 65. Today also RC coupled amplifier, feedback amplifier is there. Those days we did with the vacuum tube, then we moved over to bipolar transistor, then we moved over to what is called junction FET, then we moved over to MOSFET, then we moved over to ICs, and then we moved over to simulation, modeling, etc., etc. See, that is actually what is going. So the basic aspect of amplifier is not gone. It is still there. But the skill or the tool or the way in which we build the amplifier has differed over a period of time. See, I am actually 50 years experienced fellow, 1969 to today, 50 years. In 50 years, I have seen this evolving technology. These are all technologies, what we are going to talk. And why should you know? You should know who is the speaker, basically. Whatever the profile she gave is okay for me, actually, but I should know. I want to reinstate that my vision is to transform engineering degree holders to engineers. That means out of every engineering institution, you are not building or engineering or technology or science and engineering and technology institution. You are not bringing out an engineer. You are bringing out a degree holder of BTech or BE or MTech or ME or something like that. And we in industry, we convert them or transform them to engineers. So you should know what is engineering. I'll tell you that. To shift from teaching paradigm to learning paradigm, please understand, there is no way I am different from others is actually, I have the ability to learn new things, because in my institution, that is actually BITS Pilani, we have been inculcated the habit of learning. We don't go to Google and search. Of course, those days Google was not there. We go to the library and try to really get into that. We read a lot of IEEE journals those days itself. Not that we understood many things, at least few what should I say, some bullet point we would have understood. Probably we are practicing afterwards. Okay, reduce the technology gap. This is what I have done in many institutions as a part-time faculty or a visiting faculty. The gap between the institution and industry. You are in Nagarjuna Engineering College. I have visited. I was there in Reva Institute of Technology, and I was actually a visiting professor there. Okay, and I used to be there. I am actually industry academia relationship in United Electronics. United Electronics is a small company in the suburb of Bangalore, and I am one of the directors. I am only talking about the academia. I will never go to the industry for the working. And I was in NI India. Now I am only associated with NI India. Okay, that means if I tell you use Labview, I don't get any money. I don't get any credibility for that. I only tell you because it is useful. I say you do it. That's all it is. Okay, and I also make alchemist is actually turning any metal to gold. So I am trying to give the engineering degree holders, if they come to me, I will make them employable in 15 days, in 1 month, in 3 months, in 6 months. I will make them employable, and this is what I am doing now. And we do a lot of core engineering. I am only interested in core engineering. If somebody is asking me to teach software engineering, I will teach. But if you really ask me, sir, can you do something, some program on the say, for instance, software engineering or object-oriented software engineering and all, I will really shy away from that because that is not my strength. Okay. And another one. So you go to an industry, or your student goes to an industry, you'll say, oh, you have got a degree. But what do you know? Degree doesn't mean that you know everything. It's not possible. Okay. If I had become a lawyer as soon as I got a degree, then I would have not been talking to you. I would have been talking to probably Biden, previously Trump, or Modi, or anybody like that. Okay. A student's major is not as critical. Today, you can see in your IT or in your job profile of many of the students who are past graduated out of them, they are not using one bit of what they learned in the college. A mechanical engineering goes and talks about what should I say, Scrum or some software, and that is what he's doing. Web design. He is mechanical engineer. Okay, he's doing web design. And electrical engineering, instead of doing anything about energy or energy conservation, etc., he is going and talking about .NET based technology. And this is what is happening. Okay, so what do we need? We need a demonstrator. We have a student who comes, a degree holder who comes out of your institution with a demonstrated capacity to think critically. Think critically. That means if I give him a challenge, he should be able to say, how do I solve it? How do I bring a solution to it? Is it possible? Is it possible? What are the alternatives? Like that. And communicate clearly. See, this is what we are saying. So whenever we say people actually, your students are not good in communication, immediately they develop a language laboratory. Foolish. We are not interested in that. Our graduate must come with an ability to talk technically. That means all your projects, what you are doing, you ask the students to talk technically, write technically, clearly write down, and then bring it out. And that is what we need. Language laboratory. Oh, that English is good enough. If he wants to go to, say, for instance, some Siberia and talk about it, and that is actually, he can learn that particular language at that particular point of time. In engineering college, English laboratory is as good as waste. Okay, 15 lakhs or 20 lakhs you put it in some good tool, it will be good. Provide solutions to globally relevant challenges. Please understand, as everybody is saying, we have excellent engineers coming out of the institution. They were all very good in at least +2 level. You say a lot of people who are coming from Nagarjuna, who are coming from Chaitanya Institute or Chaitanya Academy or anything like that, they're all 99, 98% mark holders. They are not dabbus. They are not dabbus. They have got good marks, but they become average if they come to the engineering college. Why? There must be something wrong. We are not giving a challenging environment for them. That's all it is. Employers' keys. Because why I'm talking about employment is actually because employability is my goal. Everybody who joins engineering, he is not joining engineering to do some great research or anything. First, he wants bread and butter. He wants to get employed. I learned engineering not to do a lot of research. First, I want to earn my bread. Once my plate is full, then I will go and let me do some research. Let me do something. Finally, I will say, I will stand for election in MP or MLA or anything like that. Then I will keep on growing to the level of presidency. And that's all it is actually. Everybody looks for a job. And what we seek, I am an employer and we want to know what he knows beyond the classroom. That's all it is. Okay. And it's not very easy. You have to dance like this to get it. So I'm going to talk about one more thing. That means what? In life, there are infinite number. This is Sadhguru saying, not JAYARAM. Okay. In life, there are infinite number of doors, lot of opportunity. Today, actually, if some engineer who is coming out of the institution says, I am not getting employed, then there is something wrong with him. Employment is available. At 75, I can get an employment. At 30, can't he get an employment? Oh, he can get. So, it's not actually employment. Opportunities are not there. If you are diligent, you will open some of them. Diligent what? Study and earnest in application, you will open some of the doors which are opportunities and you will get employed. It could be even, say for instance, app development today. Okay, but you should be studying that. If you are brilliant, that means what? Outstanding, very intelligent, you will open many of them. But if you are vibrant, that means you vibrate along with the technology growth or the engineering growth that is happening in the industry, the doors will open for you. That has been my case study. That's all it is. I was in Indian Space Research. I was in defense industry. I was in private companies. I had started my own company. I lost money. I gained money. Today, I am very comfortable. I have done a lot of academic institution. All the KL University, I was one of the visiting professors. You just take it, actually. Reva Institute, as I told you, it is a VIT, Vellore Institute of Technology. I was one of the visiting professor. And SRM, I was visiting. Amrita Institute, I was visiting professor. That means what? If you are vibrant, they will open. The doors will open for you. That's all. Okay. And that is what is the basic Sadhguru says. And I am sure Sadhguru will not talk through the hat. Okay. He will have some idea. Okay. So I have been talking about that engineering and technology, scientist. I'm going to give you the first thing because I can teach automation in 15 minutes because it's not very difficult for people like you to learn. But you should know what motivates your student to get into automation. That's all I'm going to do. And that motivation is more or less through. And see, if you take a picture, either you take a picture of Rajkumar, or actually you take a picture of Ambarish, you take a picture of some Anantanag, or those people only I know because I'm one of the old fellow. And Anantanag movie, I would have seen many. And those type of movies, up to interval, that fellow will be dancing, that fellow, a lot of music will happen, a lot of things will happen, enjoy, a lot of comedy and all will happen. Beyond the interval only, the actual movie, the core will be starting. Okay, the core will be starting. Before the movie, actually, the people, their family will be totally separated and they will be dancing or they will be going and singing some songs, etc., will be there. And slowly they will regroup themselves towards the end. That's what I am going to do. I am going to do you. The whole thing is actually till say for instance 12:30. I will only talking about the motivating ability to the students so that you will be able to make the student should attend your class. Student should not attend your class because you have a attendance with you. No, in BITS Pilani we don't have attendance and our classes are full. We don't miss any class. Not because attendance is there. No. The minute the attendance, students start attending the class for the attendance, you have lost your gain. Okay. Now we'll come to the engineering and technology. Who is a scientist? Okay. Now let us first go to the scientist. Scientist, engineering, technology, or artist. Four things I have done it. It is not because of the degree. Please understand. It's not because of the degree. All of you know Javagal Srinath, who was a great bowler. You know Venkatesh Prasad, who was a great bowler. You know, say for instance, Venkatraghavan, yesteryear Venkatraghavan, he was a great, this one actually. You know a lot of people who have got a degree, or Kumble actually, they are all degree holders, very good degree holders, mechanical engineering degree holders, excellent people, okay? And even including Rahul Dravid, okay? They are all engineers. And what they have become? They have become cricketers. That means they have become artists. They have become an artist. The wall of the Indian cricket is an engineer who converted himself into an artist. In artists, actually, you really have to have a lot of creativity. The way in which Rahul Dravid hits a ball, the way in which Javagal Srinath bowls a bumper is different from anybody else because of the simple reason he has brought in an artistic delivery in that. So that is what is more important. An artist is somebody who is a creative fellow, okay? A creative fellow. But only thing actually, he doesn't have to have a lot of rules, physical laws and all is not there. He can be free and do anything he wants. Look at actually the Hardik Pandya. The fellow hits the sixer very comfortably. Look at Dhoni. He stumps a person. As soon as the left leg is up, he hits the stumps and he is out. Okay. This is actually what we have to do it. Okay. That's creativity. Creativity is more or less inborn, and the education only helps to build that creativity into bringing a solution. That's actually the one. Okay. So that's artist. Now we'll go to the engineer. Okay. Scientist will go. Scientist is what? You take Newton as a scientist. Actually, during the first year of engineering or second year of engineering, I was one of the very few people who used to dislike this Newton. If only he had eaten that apple and gone home, I don't have to solve this problem of dynamic statistics and all those things, statics. This one fellow will say, you have a session actually, in that actually, the car will be curving and the car should not fall or should not overturn. So they will say centrifugal force, etc., etc. Horrible, I tell you. By the time I understood the dynamics and statics, probably the second year is over. Okay, so it's very difficult. So Newton used to be cursed. Now I like Newton because of the three laws are the basic laws which he has given to solve most of the global challenges. If you know the basic three laws for every action, there is an equal and opposite reaction. Like that, you have say F is equal to ma. These are all something which if you know, you can solve more or less every physical problem or challenges that is coming in the industry, engineering industry. Okay, and who is that? See, if somebody says if Newton has discovered gravitational force, what he has discovered? It was there. Before Newton invented or created or discovered or provided the theory, the apple was still coming down only, So it's what he did for every phenomena that was happening, he did search or probably experiment and try to find a postulate or a theory for that. Every scientist does it. Okay, every scientist. You say, I am a scientist. He only understands the physical phenomena. You take Raman spectroscopy. Spectroscopy is not because of Raman. Spectroscopy was happening. This person actually provided a postulate or a theory for that. That's all it is he has done. And that is what I am saying is the basic cure. That is a scientist. Scientist is one who gives a postulate for a phenomenon which is occurring already, which is already there. Okay? And now we'll go to the engineering. Okay, we are all talking about how many engineers you have produced. I can tell you from whatever little I know, no engineer is produced. Okay, then what is engineering? Engineering is application of physical laws to provide solution to the global challenges using the creativity in that person. If you are going to do your lab through exercises, where is the creativity by? There's no point. The person has to choose an op-amp for an amplifier. And if you have to choose an amplifier, op-amp, which I'm going to talk in the third session, op-amp he has to use, he should know the physical parameters of the op-amp. That is 741 you are using. 741, when I was studying, actually 741 came. That was one of the first few IC. Even in 2020, you are using the same 741 which I used in this particular 1967, 8, 9, that type of age. What is the growth you are showing? So the person should know basically I'm going to build an audio amplifier. I need an op-amp of this characteristic. So I will search and then get this particular op-amp and start using the audio amplifier. Okay, that's how it is. It's not actually the way in which we teach. There's a board, everything is fixed, and you go and do it. Where is the requirement you are given? You are not given a requirement at all. Op-amp. See, if you go to Nashelski and Boylsted book, there are 120 amplifiers are there. And in your lab, in 3 hours, you cannot do more than 2 amplifiers. Where does the other amplifier, Cascade amplifier, Cascade amplifier, push-pull amplifier, Darlington amplifier, where is that? I'm going to talk more about it. Now we'll come to the engineering definition. So engineering is about creativity. Okay, it's about creativity. So let us take one example of engineer. Say take it actually, Edison, Thomas Alva Edison, Graham Bell, if it is electronics communication, Graham Bell, Marconi. Before Graham Bell discovered or invented this particular telephone, was it there? No, it was not there. He created, he invented, he gave a theory and gone through many experiments. Finally, he proved that there is a possibility of one person talking to another person through this amplifier, etc., through the line, and he can receive it. This is what is the basic thing. So creativity. You take Albert Wright brothers. There is a magnetic, this one, what is it called? Gravitational pull. Newton has discovered that. Okay. And then he has to take the aircraft above that particular thing and make it fly. Oh, it's not going to be easy. That means what? Engineer is one who creates a new product, invents a new product, which will obey the physical laws. That's all it is. Okay. Y is equal to mx is a linear only. Okay. There's no problem. Okay. This is engineer. So let us talk about technology. Sir, you told technology. What is technology? Technology is like this. So Thomas Alva Edison brought out one filament lamp, and somehow other he says, actually, if you really read some of the things, actually, he will say, I used some 4,000 material for getting this filament lamp. Finally, one material that actually that was finally chosen, except tungsten or whatever it is chosen. Okay, and the filament lamp came. But the other people, what they did, filament lamp is not efficient. Let us go to carbon. Then actually, let us go to, say, for instance, tube light. That is the vacuum filled, something like that. All those things are technologies. That is, from the invention, if a person can create new product, new markets, new processes to create many more and improve the salability, that is actually technology. And if at all we produce some people, we are only technology people. Birla Institute of Technology, Birla Institute of I entered into Birla Engineering College. Finally, I got a degree or postgraduate degree as Birla Institute of Science and Technology. It's technology and science. That means what? They accepted that you are not an engineer, you are a technologist. At the most, you can become a scientist. That's all. You can never innovate anything. That's what has been told. And I got a BITS degree. Okay, technologist. But that's actually one. Okay, so technologist is there. So now let us look at it. This is my explanation for that. This is taken from more or less infinite number of what we call actually dictionary and the things actually. Okay. Now I am only bothering about one or two things only. Creativity and inspiration. Okay. That's actually one. So if you are not going to have an experimental lab, which is going to do experiments, inspiration will not come. He is only doing analysis. He is only giving an explanation why it is working. That's all it is. And that's all it will happen. So it's not correct to make that particular lab like that. Okay? Technology. What is the thing he says? Create new products, exploit new markets, use new ways of organizing, incorporate new raw material. This is what it is. You take some tungsten filament lamp, throw it out, bring another element and try to build the same tube light or carbon film lamp or anything like that. That is what is actually the one. So that is beautiful. Okay, technology. Now I have just put it actually, scientists investigate which already is there. The engineers create that which has never been there. You go and you yourself have got a degree. Find out whether you are an engineer or a technologist or a scientist or an artist. You will know what it is. Okay. So it's not actually a degree will make you an engineer. It will never make it. Is actually that's not going to make it. Okay. And now I'll go to the next one. That's actually one small thing. And what is the next one? Underlying competency is experimentation. Whether you become an engineer, whether you become an artist, you know, for the ball which will beat, say for instance, Rahul Dravid, Jawaharlal Srinath, how many experiments you would have done on the ball, you know? It's very difficult for him to do it. Keep on trying, keep on trying, keep on trying. Rahul is out, so Dravid is out. Then he will say, okay, this ball, Dravid will become out. Yuzvendra Chahal is there, you know. He takes wicket. It's not because he is simply a spin bowler. No, he creates new thing. Okay, if this person is going to come for the, say for instance, Glenn Maxwell or something like that, that fellow comes to batting, he's going to hit. So give him, feed him, let him hit. Then you'll just put it actually in such a way that that fellow gives a catch to, say, Virat Kohli or somebody, again, Jadeja or somebody like that, and he's out. That's how it is. So it's a beautiful, I say. Life is like that. So whether you use Labview for becoming a scientist or becoming an engineer, for becoming a technologist, that's left to you. But Please understand, without experimentation, you cannot do it. You use any other tool, any other platform. You cannot do experiment as fast as you can do with Labview and as perfect as you can do with Labview. I can tell you that I am not being paid by NI for any of my statements. Okay, please understand. So I am now, what is the conclusion? We need to impart creativity. How can you give creativity? If a person says, I don't want to learn this. Actually, there are some people who have told, sir, I wanted to become a film institute person. My father forced me to attend this institute and I have to become this engineering college. I never wanted to do engineering. This is a statement of some of the best students in Amrita. I'm not talking about without truth. Okay. And creativity. How can you create creativity when the fellow's mind is not there? See, in your class of 60, you probably will have 3 or 4 people who have the basic inherent creativity. Try to enhance that. Try to build that creativity more and more. They will become your what should I say, torch bearers, and they will become your torch bearers. You cannot make everybody creativity. You cannot make everybody as an engineer. You can make some people as a technologist, some people as a scientist, also an artist, but you cannot make everybody as an engineer. This is a conclusion. Okay, this is a conclusion. Why Indian Institute of Science is different from IIT and IIT is different from NIT, NIT is different from BITS Pilani, is this particular aspect of it. Okay, knowledge, that's my capability, that little bit. Okay, and skill is what somebody is doing it, and competency is together. Knowledge plus skill. And what is the next one? If you want to do active learning, you have to improve, you have to build the knowledge and you have to build a lot of applications and then improve the competency of that person. The theory will not stand alone. The lab will not stand alone. This has to be dovetailed in such a way that we get the competent people out of your institutions, Competent is the best thing. Okay, now I'll get into the automation, towards the automation. Not that I have gone into automation. What is the industry trends? That's the next few slides will be industry trends. Today you are producing a person. You are not producing a person for yesterday's technology. No, that fellow should learn yesterday's technology and look at actually what are all the faults and failures in that, or shortcomings in that, and try to come out with this creativity to bring a better solution, better performance. That's all it is. Okay. So today, portable, wearable, more powerful devices. You have to make a powerful device with less power consumption, less energy consumption. So how many of you know what is the difference between power and energy? Go and look at your dictionary. Okay. And out of 90 students I interview, 3 students only can answer this question. And when I tell them that, how will you measure that? Finished. That fellow also gone. Okay. This is what is the problem. These are all the possible employment. Actually, I'll tell you, today there is no dearth of job. It is a question of only dearth of good engineers. Actually, for the last, not now, for the, say for instance, 2014 or 15, I started the venture, and 14 to 17, I was searching for 2 engineers who can fill this particular thing. I was ready to pay whatever he wanted actually. Okay. Almost 80% of the people said, I am going for the IT industry. I'm happy with them. They told very openly. The people who came couldn't survive 2 weeks with me because of the simple reason we have a very tough assignment for them. And if they have not read the data sheet of microprocessor or semiconductors or ICs, etc., they are not fit for my institute, my industry at all. So I just tell them that, okay, I'll manage myself, you go. Because I don't want to feed people who are not capable of providing money for me. Okay. So these are all the application, automotive, semiconductor. I tell you, every industry is looking for people, I say. See, some of the one company I went and asked actually, can you take some of my engineers? No, sir, we don't believe in that. What we do is actually we give internship for some of the students of the good institution. How it is good, he decides. Okay, good institutions, and we actually develop them in our environment, on our tools, on our capability, and then it's called osmotic learning. That is, that fellow moves along with that person who is excellent, and that fellow learns. That's how it is actually today. Okay. And military and aerospace today, jobs are plenty. I said jobs are plenty. Okay. You look at actually Modi's government, actually, there are a lot of bridges being built, a lot of infrastructure development is going on. Electric cars are coming and everything is coming. There is a question of dearth of jobs here. There is a question of dearth of job. There is no dearth of jobs. It's a question of only dearth of good, capable, competent engineers. Okay. You are the reason for not producing that. Okay. Now I'm going to get into the automation in a small way. Okay. Now I'll go to that. Okay. So I have a plant. It can be a telecommunication system. It can be a transportation system. It can be an aerospace vehicles. It can be a defense system. It can be energy system. It can be, that is my plant. Okay. Human body is also a plant as far as I'm concerned. The plant, while it is working, it is going to give lot of process variables. It can be temperature. It can be pressure. It can be, say for instance, in a human body, it's a glucose or the sugar in blood. All those things are possible. Okay. These process variable must be translated into through a transducer or actually a sensor into an electrical variable. What is the job of a transducer as a sensor? Converting a physical variable into an electrical variable. That's all it is. Okay, that's actually. So now I come to this signal conditioner and probably the sensor or the transducer I will be handling in the third day. You assume that this voltage is actually coming as a proper voltage to this processor. That's processor. Okay, that's also in the for third day session, and but it's supposed to be here. Okay, so the processor has got what is known as actually interface to real world signal. I will go to the next slide actually, and then come to that. This is what is a better place. Okay, so I have actually a real world interface in this this processor board, or there's a processing element, and there is a communication interface, and there is a user and debug interface. These are all the 4 interfaces along with the processing element. 3 interfaces along with the processing element, which is memory, CPU, and the timer. Okay, and the timer. Now, what is the next thing which you are supposed to do? This signal conditioner has to, the output has to be taken to the real world interface. That's a thing. Once it is taken into the way, I should program this processing element in such a way that it should acquire this particular real world signal and then do the processing. In case it needs to be controlled, this control signal should be sent to the plant. Okay, to the plant. Okay, this is what it is. So for programming, what languages you can use? You can use assembly, you can use VHDL, you can use C, you can use C++, you can use Java. Today Python is famous, and by Labview there may be Ada. So many languages have come. I just taken something which I probably know little bit, probably 1/1,000,000th or 1/1000,000th of that I know. So I have put that actually. So now what is the thing? I have a plant which is functioning continuously throughout. Once it is operated, it's done, and that will actually take a lot of process variables. That will emit a lot of process variables, and that process variables is in a physical quantity like acceleration, so many kilometers per hour, or so many squared by hour. Okay, or kilometer per second velocity or speed, and that has to be converted into electrical variable, because I want to use electronics for automation. Why I should use electronics? There are 2 reasons. One is actually I'm an electronic engineer. I should get gainfully employed. That is one reason. Second reason is actually it is much more flexible to operate, flexible to program, flexible to function and improve the accuracy. That's what I've been told, and though it continues to be there. Okay. So now what is the next thing? So I need a signal conditioner. Signal conditioner is produced on this one. This has come. Now, what is the software I have to write in this particular processor? Very simple. I have to acquire this particular real world signal into my real world interface. I have to process or analyze in this processing element. Then I can present it through their display, or I can actually display it through the local display, or I can communicate and send it to a remote display, whichever is possible. Or I can generate a counter signal apply back to the plant so that the deviated variables is brought back to the normal condition. Okay, keep that. That is automation. Automation is a plant is operational, plant has got process variable, the process variables are likely to change, and that particular change has to be detected or measured or analyzed, and then try to improve, provide a counteracting signal to the plant to bring back the deviated variables to the normal operating condition. That's all it is, I say. There is nothing great about it. So now I will use the same slide for showing you what is embedded system. Okay, there are so many people teaching embedded system, and in the syllabus actually it is much more worse. Syllabus, they think that 8051 or ARM controller is the, and peripherals is the embedded system. Please understand, you don't need 8051 or ARM for an embedded system at all. You can manage with few logic gates, properly implementing the finite state machine. That's all it is. But they will say it, and I don't want to object to it, but that particular course is as good as making it as microcontroller based system design, not really embedded system. Okay, now we'll come to the embedded system. What is the thing? Now assume that you have got this particular plant operating. Take this whole thing and along with the software and all, and put it inside the plant and make it work for them. That means what? An electronic controller built into the application, that is a plant, continuously monitoring the process variables and ensure that the process variables do not deviate. That's all it is. Ensure that the process variable do not deviate. So what you have to do, you have to write a software on that particular embedded system and try to provide the control action, and control will be provided inside, and this is all have to be encapsulated in that plant itself. That's all, embedded into the application, continuously monitoring the process variable and ensure that the process variables do not deviate. That's all it is. And next one, in the unlikely event of a deviation, now we will come to the unlikely event of a deviation should not come, but it will come. Okay, it will come due to the environment. Okay, and we will talk about the environment slightly later. So environment, it is there is likely to be a deviation, and the deviation has to be brought under control. Okay, that is what it is supposed to do. In the unlikely event of a deviation, the embedded controller generates a counteracting signal applied to the plant to bring back the deviated variable or variables to their normal operating condition. No confusion. What is embedded system? I have an electronic controller, some microprocessor, some FPGA, whatever it is. Okay, and what I'm doing, I'm programming it for acquire, analyze, control. And what I do, I take it and put it into that particular plant, and I connect the proper signal and leave it there. Once it is built in, once it is installed, it is installed for life till it is retired. Okay, so, and that's all it. What it will do, it will continuously acquire the signal, analyze the signal, generate a counteracting signal, and apply it to the plant and bring back the deviated variable. Again, it will continue to scan and find out if there is a deviated variable and bring it back to the normal condition. That's all it will do. Now we will add one more thing. What is that? Real-time embedded system. Ayyo, there is one more confusion you have. Okay, that means what? Embedded system itself is confusing for many people. Now you add one more confusion to that. Okay, confusion square. That's all it is. Nothing beyond that. Okay, confusion to the power of n is not there. Confusion square. Okay, and what is the thing you have to do in this particular? Very simple, I say. That is, when deviated variable has to be brought under control. Very beautifully told. Now you add one more element called time. Okay, that is, the deviated variable must be brought under control within 1 microsecond, 1 nanosecond, 1 picosecond, 1 second, 1 minute, 1 hour, 1 day, 1 year, 1 decade, 1 century, whatever name you want to give a time element. That means what? The real-time definition in JAYARAM's word is logical correctness with deterministic time deadline. That's all I say. Real-time embedded system is done. That means what? With one slide. And what is the advantage of knowing embedded system properly? All these industries will take you. You learn embedded system properly, not the syllabus oriented, because that syllabus is as good as waste. Okay, it will not be doing good. Embedded system, you have to read the right book, Computers for Components by Wayne Wolf. You have to read it, or you have to read from a good book. Okay, and that embedded system is applicable to all these industries. You like to take my example. I'm 75. What is the problem I will face in my life? I have a sugar problem. That's all. Major problem is sugar. Okay, the sugar is a very killing thing. Okay, killing thing. And what I do, I build an embedded system, tie it to my body, whichever part. Say for instance, my arm, one of the arms. Okay, and I am giving a lecture to you. I like lecturing, so I keep on giving lecture. And what this embedded system should do, it should keep on taking the blood from my body, see the sugar level, and see whether it is within the control. Assume for a minute it has gone beyond control. What it has to do, it has to take it, and what we should check, find out the deviation, corresponding dosage is programmed, and that dosage of insulin, you pump it into my blood sugar, finished. As I am lecturing, my embedded system sitting in my body will not disturb me. Without any disturbance to me, will make my sugar normal throughout the lecture period or beyond that. That's the beauty of this. Okay, so embedded system is as good as perennial job. I say perennial. IoT, she was talking about, IoT is basically embedded system. It's a question of only how you build it. That's all it is. Okay, so this is my view, and I'm sure. So now I will go to the next. Now I go into the application. Now I have defined the embedded system. I have defined automation. I have designed how embedded system is involved with the automation, how real-time aspect of it is added to the embedded system, how it will benefit every type of industry that you can think of. Okay, IoT, if you don't know embedded system, you are not an IoT engineer. That much I can tell you. Okay, IoT. See, look at it. I have in the complexity, in this particular car, I have a chassis, I have a emission levels, I have a brake, I have electronics in that, I have safety in that, I have engine in that, I have audio in that, I have also the durability of the car to be taken, fatigue we call, okay, and all these things. Now just imagine, this is going on expanding. I will show you the next 3 slides is only automotive. I have taken only one industry, automotive industry, because of the simple reason that is taking a lot of people into job. Even actually, if you go to Wipro, there is an automotive electronics area. If you go to, say, for instance, HCL, there is an automotive area, and you can get easily a job there. Okay, easily a job there. Now we have gone into navigation, audio processing, cellular phone, comfort, security. This is the next level. Okay. Now go to the next one. Add. Because the embedded system has become more and more beautiful. See, look at it. Blind spot warning, engine control, lane departure, adaptive control, and personal occupancy condition and airbags. Oh, you have a lot of things coming up new. And you have radar also there, yeah. Reversing sensor, radar sensor is also there. Radio detection and ranging is part of the automobile. It's supposed to control the speed also. Okay. You have a power steering, you have multi-axis sealant, you have so many things which are happening inside an automotive. And now what is the next one? You have this particular thing, which is a dashboard electronics. Look at it. You have a remote key enabled and tire pressure monitoring system, instrument cluster, head-up displays, rear seat entertainment, or radio head units, and you have navigation, you have body controls. What do you want in a car? All these things. Can your student, when he comes out of the engineer, can he understand how a system which is developed for this is working or functioning? Have you fed that information to him? Have you made him to read some textbooks and understand this? Actually, it is not necessary that you have to teach everything. It's very difficult to teach. You teach the fundamental, ask him to learn further. Of course, your management will ask, actually, have you covered the syllabus? You simply say, I am not here to cover the syllabus. I am supposed to uncover the syllabus. That's all it is. Okay. And I took this actually hybrid technology. Oh, baapre. There's one more thing which is hybrid. See, look at it. Integrated starter generator. I don't know what it is. I have not studied this further. But there is something which is new coming. Your electric car, diesel car, everything is coming up. Okay. So there are various comparisons of the energy vehicles. And now we'll come to the electronics portion of it. So I have taken from Texas Instruments. I have not hidden that. So look at it. This is actually this whole thing is power supplier. power supply. And you in your college, in your labs, in your thing, power supply is given as a low priority task. Without power supply, nothing will work here. It has to be highly reliable. Now, when I say reliable, you should know what is this reliability. What is this reliability? Reliability, how it is defined, is beautiful. Reliability is the probability that the system, service, product functions as per the designed specification at the rated conditions whenever it is called to perform. Have you made this particular thing reliable? If your power supply is not reliable, none of the systems will come. You are supposed to make actually healthcare industry self-sustaining. If it is going to be self-sustaining, your power supply should be thorough, and you are not doing it. Many of the colleges have not even introduced what we call actually the SMPS and SMPS based DC-DC converters. It's not there. It's not there. Sad. Because there is no kit available for SMPS. That's all. If I bring on kit, people will buy it. Okay. And then they will introduce something slowly and then do it. Okay. This is not correct. Okay. And you have the embedded processor. The processor, people say that 8051, ARM 11, ARM 10, that ARM fellow is keep on producing 1, 2, 3, 4. Probably he will reach 100 or 200 very soon. Okay. That's only a core, so it's available. Okay, so if you're really good at embedded processing, you should be able to develop a lot of things in this. Okay, a lot of things in this. It's a very great thing which is happening. This A to D converter. Okay, when I ask my student, engineers who are coming to the job, I'll ask him, tell me what type of A to D converter. He says immediately successive approximation register, SAR, A to D converter. Anything else you know? Okay, I want an amplifier. Which amplifier you know? I know RC coupled amplifier, sir. That's all. When do you use Darlington amplifier? When you do actually the emitter follower, when you use actually the source follower or whatever it is, when you use the 3-stage amplifier or 2-stage amplifier, how do you avoid actually the amplifier going into oscillation? We are going to talk about it on the third day, okay? Third day, because that is going to be 100% circuit engineering. Please look at actually the first 2 semesters, first 2 years are the most critical for your students to become good. Third and fourth, even if you don't teach, that fellow will follow. Okay, but first 2 you have to make him good. This is actually the processor Hercules. When I saw this processor, I was wondering how many people will understand what is this all about, because I'm supposed to be reasonably good in CPUs. I have a lot of difficulty. Look at it actually. Lockstep CPU. That means what? Reliability is the probability that the system and service and product will function as per the design specification at the rated condition whenever it is called to perform. That's actually a definition. Now, if this has to work in that particular rated condition continuously, it may not give you the reliability what you want. So what do? You do a redundant system. That is one more parallel run. And these 2 parallel must work synchronously. Now that is what is called lockstep. Lockstep systems are fault-tolerant computer systems that run the same set of operation at the same time in parallel. To run a lockstep, each system set up to progress from one well-defined state to the next well-defined. There is no actually indeterminate state at all. It is one state to the next state. Yeah, both are static. Okay, both are actually stable state, not unstable. Okay, not quasi-stable. Okay, that's what it is. And this is what is supposed to be our job. Okay, in this actually even one code is produced by one of your engineers during the VLSI design or FPGA design. Why he will not get a job in VLSI industry? I say he will get. And what he will say is actually my teacher doesn't know. Teacher is actually meant to show you the direction. We are guru. We are showing. We give on basic platform on which he has to grow higher. Okay, and it's not actually every time the student blames only the teacher and the college and the syllabus and the university. Of course, we have universities which pass students without even examination, and if you resist, actually, vice chancellor is taken to task. Okay, that's actually the problem. That is the so-called experts want to send the students out of the institution without going through a final examination. Very sad. How do you do it? So now I'll come to the thing. Research, the industry practices are research modeling, design, simulation, verification, validation, manufacturing. So what our student want? Our student should be design, simulation, verification, validation. They should be able to do it as good as within no time they should complete this. What is verification? What is validation? This is another problem. Verification, validation, we all hear. Every VLSI designer teaches this. Okay. Validation, right product, RIGHT product. Verification, product right, RIGHT. Okay, that's all. So what is the detail? You go and find out yourself. Verification is product right. Validation is right product. That's all it is. Okay, and goes to money. And if you are going to use for research, I will use one tool. For design and simulation, I will use one tool. Or this one, I will use one tool. This for manufacturing, I will use one tool. Where your fellow will learn and the tools and go. If you use only one tool or one platform for all the things, we actually in computer science, we have actually what is known as UML, Unified Modeling Language. Okay, Unified Modeling Language. Similar to that, our Labview will do. Our Labview will stretch from one end to the other end till the product is released to the marketplace. He doesn't have to learn any other platform. That's the beauty of it. Okay, and it has got such a backward compatible. If you say I have developed something in MATLAB, bring them script into Labview. I will make it work. If you have done it in FPGA or some VHDL, bring it. I will try to build it. That's all it is actually. You don't have to learn VHDL to program FPGA. Use Labview. Labview will do the remaining thing for you on the FPGA. And that's the beauty of it, We don't have to unnecessarily waste our time. Oh, then there are some intelligent faculty who will ask, that means what? You don't have to learn about VHDL. You have to learn. When you want to bring a product, when you want to do a faster design iteration, you cannot be learning too many things. You have to learn one and complete it. If you think that VHDL will give you all right from the research to the manufacturing, use. I have no problem. System C, you try. I have no problem. But if you use Labview, you can a complete thing is possible. Okay. Systems approach. This is what a system level design. Jyoti, I want to ask you how many more minutes I have.
Sir, it's already one.
Yeah, already one, but we started at 12,
Yes, sir. 10 more minutes you can take, sir.
Why don't we give 15 more minutes?
Okay, sir.
Lunch will be affected. Everybody will eat you. That's all it is the problem, isn't it?
No, it's okay, sir. 15 more minutes, sir.
But all the people will be there?
Yeah. Sir.
Oh,
yeah.
you will be there because you have to close it and go. But all the people will be there? Yeah.
Yes, sir. No issues. Please proceed, sir. So no issues of extension.
No issues, sir. We will be there.
We will be
Are you
there,
happy
sir.
till now? Wait a minute. Are you happy till now whatever I delivered?
Yes, sir.
Are you getting what I wanted to say?
Yes, sir.
Okay. You have to say yes, sir, because I'm a too old a person. Okay. Now, systems approach to solution engineering. This is what I learned in 1964, 65. I continue to use this. Okay. And so I have a system. Who is defining the boundary? I am the person who is dealing in the boundary. Okay. Boundary, once a system is there, it has some inputs and it will deliver some output. Okay. That's all it is. Now, the system has to work in an environment. What do you mean by that? I am making one embedded controller for a washing machine. Washing machine is the environment. Okay. My system is basically a breadboard or a board which contains a lot of ICs and switches, knobs, all those things, and that has to be there. Okay. And the environment, what it will do, it will actually give some external variables like say salt water or like turbulent water, like soapy water, like so many things will happen. Okay. You take a cement plant full of dust. It should not sit it. And here you see all salty water or actually the pebbles, and that will actually spoil the PCB. So you have to design the PCB in a different way. Okay. So I cannot make a system which is 100% perfect, like all the external variables. So what I do is actually I build the system taking some of the external variables as constraints. Some of the external variables. It will only take some of the external variable constraint, and that constraint has to be there. That means what? Now I have a product. I have a boundary. I have an input. I have a set of inputs. I have a set of outputs. It's going to work in a certain environment, and it's actually external variables will there. Take one example. I will give you one example. I will do it actually. Say, for instance, I want to make an amplifier for an automobile product. Okay, automobile product. Automobile, the basic thing everybody will look at it is maintainability. Correct? Maintainability. That is, I should be able to service it. In case I find some fault, I should be able to repair it and replace it, or repair it and repair or replace, and then go about it. This is what is the basic thing. Okay. Now, assume for a minute, the same amplifier, I am trying to use it in an aerospace or missile or some satellite launch vehicle. Maintainability will not be there. Who will maintain on the air? I say nobody will maintain. So what I should do? I should ensure that reliability is more and maintainability is less. That's all it is. So I am more interested in the reliability, not the maintainability. So when you are these external variables and constraints are two sets of things. Depending upon the product application, your design has to change. There are two types of design. One is actually the circuit design or the board design. Second one is engineering design. So the engineering design. Suppose you make an amplifier, use it on in your lab, and use it just outside the room. The amplifier has to be different. Outside room, rain will come. So many things will happen. It will get moisture. So you have to do engineering design different. That's what is the basic beauty of this. Okay. Now what is the next one? I have to identify. Please understand, I have not come into whether I'm going to use 8051, whether I'm going to use op-amp, whether I'm going to use resistor or a capacitor, what type of capacitor, what type of resistor. I don't know anything about it now, as of now. Okay. Then I come out with the functionality. That is, if these inputs have to be there, what functionality? These are all the inputs which is going to come. What functionality I should be able to implement here so that I'll get this output. That's a basic thing. Okay. Now look at it. Now these functionalities are defined. Okay. Now you have to write the functionality in such a small. Take input from sensor. Find the fault condition from the sensor. Like that you should basically write, and then your functionality will be probably 100 or 200 functionalities in this particular block of system. Now comes the actual implementation. Now it is up to you. See, for instance, in some of the functionalities I will implement in hardware, some of the functionalities I will implement in software, some of the functionality I will use it as a humanware. What is humanware? Humanware is not GUI, it's user interface. No, it's not user interface. It is like a switch, knobs or potentiometer, those type of things. Okay, that's all it is. So a system way of thinking is good. Okay, and that is what is basically to be calculated. This is actually, I teach this particular subject more or less to all engineers who come to me, and it will take 7 days of 8 hours, no lab session, but lot of experimental session and exercise session and total guided tour, and then develop it. 7 days it will take, 7 working days. Okay, and the students will be given, the people and learners will be given a lot of tasks, and they have to complete it. Okay, and they have to decide how they will implement it. See, for instance, today, assuming that I am the person who is going to implement this, I am basically a graduate from 1967, postgraduate from 1969. At that time, microprocessor was not there. Okay, at that time, software-based functionality implement was not there. So what I do, everything I'll put it in hardware, and I am excellent in hardware development, and so I will do it actually. Say same thing I give it to today's engineer. He will try to reduce the hardware because hardware knowledge is less. He will take a small board, whichever is available for 2,000 rupees, 2,500 rupees, and then try to build a lot of software-based functionalities, and he will get it through. That means what? Depending upon the time of implementation, the capability of the user or the designer, the functionality will be apportioned to hardware and software and humanware implementation at that particular instant of time. That means I can take some software into hardware or take some hardware into software. It depends upon my flexibility is so great because I know how I implement it. This is what is the thing. Now I'll go to the next one. I have a problem. Look at it. Okay. I want to actually make an automatic door closure. This is a simple thing, okay? Simple thing, automatic door closure, okay? This automatic door closure, the door is a mechanical device which a lot of sluggishness, lot of inertia, okay? So nothing will work in 1 nanosecond, 1 picosecond, 1 microsecond. It will work in few milliseconds, okay? You take actually a contactor or a relay or something like that, okay? A relay closes in 5 milliseconds or 2 milliseconds. A contactor closes in 200 milliseconds. Suppose I am giving an output, I am giving an input to the relay. Relay will NC to NO or NO to NC will happen after 200 milliseconds. So, in my embedded system, I have a 3 region. I have a region where all the processing is done very fast. I have a region where it is little slow, but not very slow. There is a display, this actually actuator and sensor is very slow. The embedded system designer should not send 1 nanosecond pulse to the door closure. It will not work. It will not work in the sense. See, what is the problem is actually we have to be optimizing in power also. Okay, energy consumption. If you take 1 nanosecond pulse and all, it will consume huge power. Give 1 millisecond, give 10 millisecond, no problem. That's how it is actually done. And the bringing a coherence between all the timing element is the essential for an intelligent, competent engineer. Okay, and this is what I was talking about. This is my days. That means JAYARAM day, 1967-69, and this is the day of 2020 or 2015, and there will be another date which will be only this much will be hardware. Software will be huge because software is improving. The processors are all improving. Okay, so now you have actually this type of things will happen. And your student must be able to handle this. Okay, product design process. I will postpone this actually. I'll just tell you about the automation. Or another 3 slides, Jyoti. Please give me time. Okay, the job position. I always tell people that you have to match the requirement. The college, if it is teaching actually some subject which has no relevant to employment, it will not be accepted by students. Please understand, there was a time when Java people were in demand. You are not having, it was not there in the course. The students went all the way to Java teaching places, learned Java and got themselves properly employed. So they will go. Wherever there is water, the birds will fly. That's actually beauty of this particular industry. So you have to ensure you understand. Who are you? You are a faculty. Distributed control system. Oh gosh, what is this? You have to understand. Process control network, PLC. You have to understand. Okay. Now look at it. This is actually what is the beauty of this whole job. Carries out various studies to improve instrumentation, electrical system safety, reliability, economics. Okay. Application experience requires. This is the requirement. Distributed control system, Honeywell or something like that. Programmable logic controller. Sorry. Programmable logic controller. See, they also tell you, I want from Allen Bradley, I want from logic control, logic platform, all those things. Understand the instruments like some mass flow meter, online analyzer, basic instrumentation, electronics in a hazardous area of refinery and this one. Okay, sorry. So what is automation? Why automation is required? I have just written it, but you can think of, you are more imaginative or creative more than me. So you can say, I say productivity, cost of the product. When you have automation, cost of the product positively comes down. People in Taiwan have automated. That's why their PCBs are much cheaper compared to the PCBs which are made in India, because we don't have volumes. Okay, we are not producing for global consumption. If you produce for global consumption, it will be less. Why atta in I'm talking about Godi too. That's actually the rice flour. Godi wheat flour is cheaper in Patanjali than this one. There is a production. Okay, cost of the product, volume production is possible in short time. Repeatability, the same specification will be met all over the way. See, there is you are making, say for instance, a cake in your house, and you are seeing a cake in Asha Sweets in 8th class in Malleshwaram. There will be difference. And that fellow, whether you buy this packet or that packet or that packet, it will have same taste. Why I'm talking sweet is because of the simple reason you are nearing lunch. Better ask your wife or somebody who is cooking for you to make good sweets. Reliability and safety, configurability, that's what it is. You can add more. What is automation? This is a question which everybody is asking. Suppose I want to get a job in automation. What I should know? Okay, I should know this. Acquire, ability to acquire from anything. Human being, how do I acquire? What type of A to D converter I should use? What type of signal conditioner I should use? If I am going to be taking from a cement plant, what type of signal conditioner I should use? What type of sensor I should use? All those things. And measure and comprehend. Measure that particular value and analyze whether it is greater or less. That's a basic thing. Whether it is audio processing you can do or image processing you can do, and then you can do display, communicate, or control. This is what is a basic thing. That is, if you can tell your student, hey, you specialize in acquire, the remaining things you read less. Okay, so it's up to him to decide whether he wants to do one or he wants to do all. That is up to him. But if you want to be in IoT, you should basically have a set of 3 people who will be good in all the things. Okay, so you should basically know. This is again my basic beautiful diagram. This is automation. Embedded system is an electronic controller built into the application, continuously monitoring the process variable. Ensure that the process variables do not deviate. In the unlikely event of a deviation, the electronic controller generates a control signal and apply to the plant to bring back the deviated variables to their normal operating conditions. That's all it is. Okay, and that's the beauty of it. Okay, and next one is actually what is real time? Logical correctness with time, deterministic time constraint. That's all it is. There is nothing else. No great rocket science is involved in that. Okay, this is one of the match manufacturing line I thought, and these are all the various different controllers which are there. All these things have to be coordinated, and this one. How to automate? Actually, PC-based automation is one, embedded automation is one, centralized automation is one, distributed automation is another. Okay, so Jyoti, give me one small. I have one request. I'll continue to tell the request. Okay, that is,
Yes, sir.
I will actually close the session now. Okay, tomorrow morning. Okay, tomorrow
Okay,
morning
okay.
when I have my session at 9:30, I will spend
Yes.
about half an hour to complete this particular thing and then proceed with the communication system engineering, design, and this one. That means what 3 days, I will try to cover almost what I want to know, what all the faculty to know. Please understand, anytime you want a change, I have my email address. You please let me know, Jayaraman, we would like you to spend more time on this, less time on this, etc., etc. Or say, everything is fine, sir. You continue whatever you want to say. We will do what we want to do, actually. That's also okay for me. No problem for that. And with that, actually, I thank you all for the excellent time you have given me to present this one actually to you all. And I enjoyed my session with you. Hopefully, you learned something from here. And I have given you enough pointer for you to learn much more than what is given here. And please go ahead and try to do that actually. With that, I close my session, and it is Jyoti's time to say whatever she wants to say. That's all.
Thank you so much, sir. Participants, if you have any queries regarding this or any questions, please let us know in the chat section, or you can unmute yourself and you can ask the question. Any questions?
Am I correct, madam? Lunch is more important than all these things. Sir.
Yes, yes, sir.
115 hungry stomach. How can you ask question and get this answer? This old man will keep on talking, I say. Like that, there are some people who will say that. But still, Raja Parisami will like it. Okay?
Okay.
Okay.
So now we are leading towards the end of the session. I would like to thank Professor K. Jayaram, Competence Developer, Bangalore. Thank you so much, sir, for sharing your knowledge on teaching and learning automation engineering through graphical system. We are pleased to have you as a session speaker, and your years of research, your depth of understanding and ability to present the subject in such an interesting way is really commendable. We thank you again for your wisdom, experience and informative presentation. Thank you, sir.
Looking forward to see you at 9:30 tomorrow morning.
Yes, yes. I would
Don't
like to
miss
thank,
it. It will be very interesting session.
yes, sir.
Okay,
I
thank
would
you.
like, yes,
Ma'am,
yes.
afternoon, no session is there?
At 2 p.m. we will be having the third session.
Okay, ma'am.
Yeah, I wholeheartedly,
How long? 2 to 3:30?
yes, ma'am, yes, ma'am. We have from 2 p.m. to 3:30 p.m. on introduction to NIGSD software platform.
Okay. Okay.
I would like to thank Dr. Nagesh Kain, Program Coordinator, as well as Professor and HOD, Department of ECE and CET. I would like to also thank Dr. Rohit S., Program Co-Coordinator, Associate Professor, Department of ECE and CET. I wholeheartedly thank all the teaching and non-teaching fraternity and the participants for your valuable time on behalf of NCET. Thank you, everyone. We can join for the third session at 2 p.m.